Hey guys, welcome to the third in the lecture series of Precalculus. Today we're actually going to be talking about properties of algebra. There are a few properties that we'll cover today. It won't be all of the properties that exist in algebra because that's a little beyond the scope of this section of the course. We'll get more into it later. So before we even get into properties of algebra, some prerequisite that you'll need to know is what a variable is. What in the world is a variable? A variable, generally represented by some letter, you might have seen it as X, Y, Z. It can be A, it can be a apple, is a cherry, but whatever, you get it. So it can be represented by anything. So a variable is just a placeholder for some value. So if you imagine a box, and this box is called X, the name of the box is X, we can put 4 in the box, and now X is equal to 4. Sort of how I like to think of it is it's a placeholder for something. So if you have another box, let's say Y, and that is some value 5, and now Y is equal to 5. So one of the biggest things in mathematics is that variables are called variable because they can change. The variables can vary depending on time, depending on mass, it doesn't matter. So, it's like if you're moving positions from one place to another, let's say you're on some road and this road is called X. Let's say X is the distance you've traveled actually on this road. And if you start here, maybe this is 1 and 2 and 3. If you start here, and if X is your distance, you're starting here at 1, so X is equal to 1, but when you move here now, X is equal to 2, and so on and so forth. So if you move here, you're at X is equal to 3. So a variable can change over time or anything. It doesn't have to be time, it can be based on anything. And a variable that doesn't change, a variable that doesn't change, that does not change, is called a constant. Is a constant because they're constant forever. So these are two important terms to remember, a variable and a constant, even though a constant is technically a variable as well because it can be a placeholder. So if it doesn't change, it's a constant. Say, um, like if W is the mass of me and I'm 200 pounds, it's going to stay the same until I lose weight. But let's just say for now, it's going to stay the same. So let's go over into some of the properties of algebra. So now that you know what variables are, we can actually start going into some of the laws. So some of two or three of the most important properties that you'll need to know now that you know order of operations are there's the commutative property, commutative law or property. This means if you have some variable A plus some variable B, it doesn't matter how you add them. If you had some, this is the same as b plus a. So say you had some number 5 plus 10, this is always going to be the same as 10 plus 5. The commutative property applies to the single operations of addition and multiplication. You couldn't do this with subtraction because if you had 5, let's say a minus b, that's not the same as b minus a, right? If you did 5 minus 10, this is not the same as 10 minus 5 because this side is equal to 5 and this side is equal to minus 5, right? So it's not equal. Whereas this is 15 on both sides. And this can be done with both addition and multiplication. So you could do A times B is equal to B times A. So the order doesn't matter. So it's a swapping law, I guess. And you can do 5 times 10 is the same as 10 times 5, whereas this is, 50 on both sides. You couldn't do this with division though, because if you did A divided by B is not the same as B divided by A, right? If you did, let's take the same example, 5 divided by 10 and 10 divided by 5, you're getting totally different numbers. If I'm doing this right, 5 divided by 10 is 0.5. here is 5. See, magnitude and difference right there. So that's the commutative law. It means you can swap and back and forth. So let's do maybe an example of commutative law. Or actually, let's leave that for later. So let's move on. Whoa, I'm already at the end. My bad. Let me go up and erase some of this right here. But we won't need this for the rest of the lecture. So hopefully you guys remember. Otherwise, this is gone. And there we go. So now let's try the next law, which is called the distributive law. This is another really important thing to know. Distributive law. Distributive law. Whoa, I don't know where that went, but it's okay. Is if you had some A times B plus C, this is equal to AB plus AC, right? You got to distribute the A to both sides. So let's do a real life example here. So let's do something like 4 times 2x minus 7, right? 4 times 2x minus 7. These are just variables. This just means 2 is being multiplied by some placeholder x that we can set later. So for example, let's just change colors here. If 2x, right, and we want to set, let's say x is equal to 5, all we have to do is do 2 times, substitute the 5 for the x, and you get 10. So this can vary over time. So we can just leave it as the variable itself. So switching back to the color that I want. Okay. So distributive law. So what do you do? To distribute, we kind of just follow this pattern here. We start outside the bracket and we push outwards, right? So we're doing 8x now minus 28. And then if we wanted to plug the 5 in, we could at the end, which would be 8 times 5 is 40 minus 28. And then we can solve this. This is something like 12, right? And so that's the distributive law. Distributive property lets you distribute out things. And keep in mind, this can be combined with the associative law. So the associative law means you can swap multiplication. So this right here is a multiplication, right? So it's this A times B plus C is the exact same as writing B plus C times A. We can take this another step further. This is also the same as writing C plus B times A because these can swap. So if we were to use distributive law, we take whatever's on the outside and multiply with whatever's on the inside. So we can just go like that. And so that's CA plus BA. And this is the exact same because if you were to plug in values, we get the exact same answer. And so that's the distributive property. There are a few more properties that we'll explore, but I want you guys to kind of wrap your mind around this. And now with the combination of this, and you have the knowledge from order of operations, you should be able to solve any kind of simple equation using these and be able to simplify them all the way down and get the correct answer. So as per usual, I'm going to link some practice problems in the description and make sure you like, share, and subscribe. And I would love to know what you guys would want to see and how I can help you become better at math and what other topics that you guys are interested in because I plan on doing all the way from pre-calculus to calculus to differential equations and physics and computer science. And if you're interested in all of that, make sure you subscribe. And that's it for now. I'll catch you guys in the next one.